Welcome everybody, welcome to Maths with Kuan Chan, and we are back again with the fourth and final part of coordinate geometry, which is equation of the locus. Okay, alright, what is a locus? The locus is the path taken by a moving point. So if you have a point that's moving on a Cartesian plane, let's say this coordinate, it moves, okay, it's moving. So this path taken, okay, the path taken, this is the locus. The path taken by a moving point, and your job is to find the equation of this line. Sometimes it's a line, sometimes it's a circle. So your job is to find the equation of the locus. Okay? Alright, number 2. For the most of the questions in locus, we use the distance formula. Remember the distance formula we learned last time? Yes, this is the formula we're going to use most of the questions. Okay? Alright, now in our syllabus, there are two types of locus that you're going to learn about. The first one is this, and later we'll do the second. Locus of a moving point R from a fixed point is a constant. So now you're going to do this one. A locus of a moving point from a fixed point. Okay, so let's see this example. Find the equation of the locus of a point R. So R is moving, which is moving at a constant distance of 6 centimeters from a fixed point P. Okay, let's say we got a fixed point P here, and the point R is 6 centimeters away. Okay, let's say it's here, 6 cm. This is your point R. And point R is moving such that it is always 6 centimeters away from P. So, what do you think? How do you think the R is going to move? Yeah, it's always 6 cm away from P. So, it will probably move in a circle with a radius of 6. That means if R is here, the distance here is 6. If R is here, distance here is still 6. The distance from P to R is a constant. Okay, it's a constant distance. So no matter where R is, it's 6 cm. Therefore, the path taken by the R moving point R will form a circle. And your job here is to find what is the equation of this circle. Okay, how do we find the equation of this circle? We are going to use the distance formula. Okay, now step 1 is, first you let the coordinate, the moving point R, let it be xy. Okay, let R be xy. Okay, then step 2, we know that distance of P to R is 6 cm. Okay, because we are given here that R is always 6 cm away from P. So we know distance of PR is 6 cm. Now we use the formula of distance of P to R. So this is x2 minus x1, x minus 1 squared plus y2 minus y1, y minus 4 squared equals to 6. Okay, we use a distance formula, we get a connection between x and y. Now we need to expand this, so we square both sides first to get rid of the square root. We square both sides, means we square here, we square here. So now the square root and the square will cancel each other off. So you are left with inside here only. And now this one we got to expand it. So we expand this one. So x squared minus 2ab plus 1. Expand this also. Okay. Y squared minus 2ab is going to be 8y plus 16 equals to 6 squared is 36. Bring the 36 over. This is the final step. So expanding is third step, and the final step is, when you write the equation, you put everything to the left and on the right must be 0. Okay, so we can arrange it nicely. So x squared plus y squared, okay, x squared plus y squared minus 2x minus 8y, and the numbers will add up. 16 plus 1, 17, and when we bring the negative 36 here, 17 minus 36, 17 minus 36, what do we get? Minus 19 equals 0. And this is your final answer. So what we have found here is actually the equation of this circle. Okay, so that's how we find the locus of a moving point R. Okay, I repeat. Step 1, let the moving point have a coordinate of x and y. Don't forget. Step 2, look at the question and see what is given. The distance of PR is given as a constant. Then we use the distance formula, okay, using the coordinate R and the coordinate P. Okay, R and P, use the distance formula, expand it and bring all to the left equals 0, and that's your answer. Okay, equation of the circle. Alright, we'll see some more examples. Obviously the next type of locus, we have two types. Alright, this is the second type of locus. I remember I told you there are two types of locus. One is a moving point R from a fixed point, from one fixed point P. But now this one is a moving point R which has a constant ratio between two fixed points. Okay, between two fixed points. Earlier one was one fixed point. Okay, so that means you have two fixed points, point P and point Q fixed, and then you have this moving point R. R is moving, okay? It is moving, how is it moving? With a constant ratio. Let's look at this. Find the equation of the locus of a moving point R such that the ratio of distance between P and Q is 2:3. That means they are saying, first step, you let the moving point be xy. Okay? Now second step, they have given you that the ratio of the moving point, that means RP to RQ, moving point R, such that the ratio of the distance from P and Q, so R to P, ratio R to Q is 2:3. So this is given. That means your R is here, R to P is 2 parts and R to Q is 3 parts. And it's moving this point. We don't know how it's moving. Maybe it's moving like this. Wherever R is, if R is here, the ratio here is 2 parts is to 3 parts. If R is here is 2 parts and here is, the Q is 3 parts. So this moving, we don't know how the shape is, but we are going to look for the equation of this locus. Okay, the locus of R. Wherever R is on this locus, remember the ratio is 2:3. So when you read that, distance from P, you write down PR, RP to RQ is 2:3. Now once you got the ratio, next step is to change it to a fraction. You write RP over RQ equals to 2/3. Okay, the ratio you must always change to fraction. Then only you can do the question. Now once you got this, you cross multiply here. So we will get 3RP is equals to 2RQ. You all okay? First thing is write down the ratio, change ratio to fraction, then we cross multiply, so we got this. Now we use the distance formula. Okay? 3. What is RP? We use its distance of RP. Distance of RP, we use the distance formula. Okay, so R is xy. Okay, R to P. Okay, this is R. So x2 minus x1, this is x minus 0, plus y minus 3 square equals, the other side, 2 RQ. RQ is also using the distance formula. So x minus, where's Q? Here. X minus 5 plus y2 minus y1. Okay, we are using the distance formula, step 4. Alright? Okay, step 5. Now we're going to solve this. First thing, you want to get rid of the square roots. So you need to square both sides. That means this whole thing squared and this whole thing squared. When you square it, you get rid of the square root. but the square is applicable for this and also for the number in front. So you don't forget 3 square must become 9, and then okay, this one square with the square root will cancel off. Okay, so this one expand this. Now you expand this, you get x squared plus expand this, you get y squared minus 6y plus 9. Okay, the other side same thing. The square is applied for the number in front as well as the square root. Okay, so 2 square becomes 4 bracket. Okay, this one we have to expand it. Okay, the square root will cancel off, so you're left with all this. You expand this, you get x squared minus 10x plus 25 plus expand this, you get y squared minus 2y plus 1. Okay, you know how to expand, right? Expanding a square is using this formula a plus b square. Okay, like this. Square becomes a squared plus 2ab plus b squared. Okay, this one you must have it in your fingertips because we have to do fast. You cannot do slowly. So memorize and practice. Okay, so this whole thing becomes here and this one becomes here. Okay, next step will be times the 9 in every single number times the 4 in every single number. Okay, times it all in and bring everything to the left and get your equation. So let me write it down. Here you get 9x squared plus 9y squared. Here I times in, I will get 100. Yeah, it's very long, but that is a bit tedious, but not difficult. And that's your final answer. Okay, so you understand how to do this? I repeat, there are 2 types of locus. Okay, when you read the question, you will know whether it's from the distance from one fixed point or from 2 fixed points. If it's 2 fixed points like this, they will give you a ratio. So what you do, best is you can, when you read the question, step 1, let the moving point R be xy. Step 2, you write down the ratio as given in the question. Alright. Step 3, change ratio to fraction. Rp over Rq equals to 2 over 3. Change to fraction. Step 4, cross multiply, and we got an equation here. 3Rp equal to 2Rq. Once you're done, step 4, use the distance formula. Okay, Rp use the distance formula, Rq use the distance formula. Now we're going to solve. Step 5 onwards is to solve it. Okay, so you square both sides to get rid of the square root. But when you square, make sure you square the number in front becomes 9 here. Square the number in front becomes 4. Then the square and square root will cancel each other off, and you're only left with all these brackets inside to expand. Okay, expand all the brackets using this formula and bring everything to the left and all and equals to 0 on the right, and that's your final equation of the locus. Okay, I hope you understand locus. You should be able to do. We'll do some practice, homework, all must be done. Okay, thanks for listening. Take care and bye bye.